Good afternoon, students. Let's start with the class. This is the last topic of the chapter, but many problems to be solved. So next class I will finish with the portion. Friday I'll have to solve some problems. But the topic wise, it is the last topic. So all the problems which are left are now completely based on Bayes theorem. So just write this Bayes theorem. This is the statement. What is there? Bayes theorem. Just write this, then I'll explain, and then we'll prove it. Okay, Bayes theorem also sometimes in the exam they ask state and prove Bayes theorem. Yes, so that was the statement. So these are the same three conditions which we did for partition of sample space you are assuming. So which were the three things? First is they are all disjoint. Second one, it has non-zero probability. Third one was third condition. Anyways, this is so when you add all this E1, E2, E3, okay, up till En if you add, it will give you the sample space. So these three conditions you have to assume in the statement. So the statement itself says if E1, E2, E3 up till En are the non-empty events, means what? A non-zero probability, which is of a sample space S. And if E1, E2, all of them are disjoint, and such that E1 union, E2 union, all that En gives you the sample space, and A is any event in that. So assuming A is any event, then the Bayes theorem says P of Ei upon A upon, if you notice, this is nothing but the total theorem of probability. This is total probability theorem. Instead of I have just used the letter J because I have already used for this. So we'll prove this. So this is, if you see, this is ulta. Usually we used to always see A upon EI. If you have attended a previous class problems, all the problems which we have solved was A upon E1 or A upon E2, A upon E3 like that. But Bayes theorem, there's one something which you have to find out ulta. So that I'll explain while solving the problem. Basically this is, so by conditional theorem, we'll apply the conditional theorem for this. A formula of conditional probability. What is a conditional probability formula? Therefore, P of A upon B was what? P of A intersection B upon P of B. This is a conditional formula. A upon B is equals to A intersection B upon B. Same way, if we had B upon A, then it would be A intersection B upon P of A. So as per that logic, P of EI upon A will be equals to this intersection this. If you want, you can use N also, but you can, after dividing by sample space, it will be anyways P. Now for this, apply multiplication theorem. What is A intersection B? You can write it as P of A. If I am taking splitting this, what does multiplication theorem say? P of A intersection B can be written as P of A dot P of B by. If this A I am taking here, it should be there in the denominator. So I have applied multiplication theorem of probability for A intersection B. So it is P of A into P of B by, that way. What is my total theorem of probability? P of A is what? Previous class we have done this formula. P of E1 dot P of A upon E1 plus, if we just go on multiplying, the last one P of En dot P of A upon En. That is for En, which is can be written as summation. Okay, we'll use the letter J here. Only this is changing, rest is remaining the same. This is total theorem of probability already done in the previous class. So same this value PA you substitute here. And so PA put this, so that will get the answer. So three formulas you have to apply. First one is the conditional, second one is the multiplication theorem, and the third one is the theorem of total probability theorem. So these three formulas, and this is the proof. We'll start with the problems. Extremely important. One sure question on this for 4 marks. The first question. They look similar to theorem of total probability. I'll explain you the difference. How to understand if it's a total probability theorem or Bayes theorem sum. Okay, which type you have to solve. They look similar. First one, bag 1 contains 3 red and 4 black balls. Bag 2 contains 5 red and 6 black balls. A ball is drawn at a random from one of the bags and is found to be red. What is the probability that it is drawn from bag 2? Okay, so first I'll frame both the ways how it would have been asked in total probability and how it is asked in Bayes theorem. Try to understand this first. If it was asked for how you would know it is for total probability, whether it is Bayes theorem. Previous class problems which we did are total probability theory. How this data is given. Same data if it was given 3 red, 4 black. Here back to 5 red, 6 black. Same data given here also 3 red, 4 black, 5 red, 6 black. Bag 1, bag 2. Data might be same. Now look at how the question has been asked. This is also same. A ball is drawn at random from one of the bags. Here also they say the same thing. And ball is drawn at random from one of the bags. Till here, this question remains the same for both the things. Now, if I ask this now question will be, what is the probability? Till here, this and this is same. Now, this is what you have to check for. This question makes a difference. In any ways, in any of this, you are picking a ball. From which bag as of now? You don't know. Now, what is the probability that the ball is red? So, this would be the total theorem probability. What you would do, the main event would have been red. Okay, ball drawn is red. E1 would have been, now there are, when I go and ask you, there are 2 bags. So either you could pick this bag or this bag. So you had 2 options. So E1 was the bag 1, E2 would have been bag 2. Then we had to find P of A upon E1. That is what? Red when it is bag 1. Given that bag 1 was picked, this. Then we have to find P of A upon E2. Red when bag 2. Then P of A would have been what? This into this into this. So this is how we solve theorem of total probability. Straight away asked, what is the probability that the ball is red? So it could have been black also, it could have been red also, but they are asking probability of a red ball. Now see this question, now which they are supposed to solve. They have asked, a ball is from this, but they are already telling it is found to be red. This is already given. You already know that the ball which is out is red. A red ball is drawn. Here we did not know whether it would be red or it could be black. We were finding what are the chances that it could be red. Here you are sure that it is red. The question main here is, this is still the data. The question is, what is probability that it is drawn from bag 2? Now they are asking what is the probability it is from bag 2. Given that the ball is red, what are the chances that you had selected bag 2? Here the question is what? One ball is picked up straight away. What is the probability it is red? Here there will be something given and then ulta you have to find whether it is from bag 1 or bag 2. So this is the difference between total probability and Bayes theorem. Again repeating, here you are given a task. I go and tell you, go pick a ball from one of the bags. So you go, you pick a ball. Now I'm standing at one place and trying to think, what are the chances that you must have picked a red ball? This is this calculation. Okay, now here, this is the question. I give you a task, go pick a ball and come. Now you already come to me saying it's a red ball. The ball which you picked is a red. Now I have to sit and think whether you had picked it from bag 1 or bag 2. Here it did not matter from which bag you picked as long as what are the chances of it being red. But here it is what? You know what you picked is red and now you have to find which bag you had picked from. This is the difference, probability. This is a Bayes theorem. So there will be always a given that this thing will be given and you have to find ulta. Whatever outcome is there will be given. So the same problem will start with the first one now. These are all Bayes theorems problems. So first one, what is data has been given? Bag 1 has 3 red, 4 black. Bag 2 has 5 red, 6 black. You know that one of this it is red given. Probability that it is red is been asked. What is the probability that it was from bag 2? This sequence will always remain the same, I told you, irrespective. P of A, then P of E1, P of E2, then P of A upon E1, P of A upon. Irrespective whether it is total probability or whether it is Bayes theorem, these you find and keep. So what is your main event? Main event is that what is the outcome? The main ball which has been drawn. So ball drawn is red. Or you can directly write as P of A probability okay, or you can best option, no confusion, ball drawn is red. What will be P of A? P of A will be probability. This we don't need, later we'll come to know. You just write and keep as per the formality. A is what? The main event, that the ball drawn is red. If P of A we have to find what are the chances that the ball drawn is red, then it would be total probability theorem. But as of right this. Now this part is done. Now we'll consider E1. There are two bags, so we don't know which bag was picked. So when you are given a task, you are going here, you have two options, either to pick bag 1 or bag 2. So if you are going for bag 1, how many options you had? We are considering bag 1. So you go here and maybe you probably select bag 1. So what are the chances? 1 out of 2. When you select a bag 1, how many options you had? 2 options. So you are selecting 1 bag out of 2 bags. If there were 3 bags, then it would be 1 out of 3. Then E2, bag 2 is selected. Probability of E2 will be 1. Again, half only. For this one also, 1 out of 2. If you go to bag, pick bag 2, again, you are picking 1 bag out of 2 bags. So which is done? This part is done. Now this, P of A upon E. Read now. This I told you, always start here. Given that bag 1 is selected, A means what? P of A means probability that the ball drawn is red. Ball drawn is red. Given that bag 1 is selected, probability that the ball drawn is red. So if bag 1 is selected, what are the chances for it the, so you are going here, given means assuming that you had gone and selected bag 1. So how many options of red you would have to pick up? 3 red options, no, out of 7 balls total. So P of A upon E1 will be 3 upon 7. So this is for red. 3 red balls out of 7 for bag 1. The same thing you write for P of A upon E2. This is done. Now last one, P of A upon E2 we have to find. Given that bag 2 is selected, probability that A is always same thing, ball drawn is red. So in bag 2, there are 5 red balls out of 11. Total are 11 balls in bag 2. So 5 out of 11. 5 of a red. If black was asked, it would have been 6 out of 11. So all this is done. Now check. Can I now find what is P of A in the, if P of A, when I would find P of A, I would find if it was asked what is the probability that the ball drawn is red, like I told you in total theorem of probability. But now here ulta has been asked. So what is asked? Probability so remember, it will always be something ulta, either of this one's ulta or this one's ulta. So what has been asked? Given that the drawn ball is red, probability that it was drawn from bag 2. Given that means where we always write, I told you, given that the drawn ball is red means A will come to the denominator. Given that the ball drawn is red, probability that it was drawn from bag 2. Bag 2 means E2. If they had asked from bag 1, you have to write it as E1. till this part is as it is. Now just only it will be ulta of this one or this one. So now it is bag 2, so it is ulta of this. This is for bag 2. Now we'll apply the Bayes theorem formula. Very simple. We have to basically find this. Given that the ball drawn is red, what is the probability it is from bag 2? It will always be, if this is E2, no, this will be always E2. Or one thing you do, if this is confusing, you have to find P of E2 upon E. Okay, denominator will always be total probability theorem. Here denominator, it will always be this into this. Same thing how is to write now, because this is P of A here, denominator. So this into this into, so write the denominator first. And this into this. Denominator is always this into this plus this into this. If there were 3 events, then it would be 3 terms. Now what to write in the numerator here? Either this will come or this will come. Which is this asked with reference to second one. So this will come up here. Now just substitute the values, that's it. P of E2 is how much? Half. P of A upon E2 is 5 upon 11 upon P of E1 is half. A upon E1 is 3 out of 7 plus P of, this is E2, sorry. So E2 is half upon E2 is 5 upon 11. And now you have to calculate. This will be 5 upon 22 upon 3 by 14, 5 upon 22. Then cross multiply. 5 upon 22 upon cross multiply 3 into 22 plus 5 into 14 upon, don't multiply 14 into 22, just keep it like this. Then this will become ulta. So this will be the answer, 35 upon 60. That 5, 22, 20 and 22 will cancel. If you are not understood, having some doubts in the first one, second one. Okay, there's the same question. That question too. Sometimes they asked in terms of shoes. There was one more question which had the same numbers, but they had used toys. Okay, so maybe I have mixed up the thing. So we'll keep it everything toys only instead of shoes. Now that last, there will be a correction then. The toys are produced by two machines A and B. So basically there are two machines. So 50% toys are produced by machine A with estimate of 10% defective. In machine B, 20% are defective. If a toy is taken at random and is found to be defective, what is the probability? Here the toy you use instead of shoe, it will be toy now. If the entire problem you are keeping in terms of shoe, you can keep it as shoe. Or else everything change it to toy. What are the chances that it was produced by machine A? Same way, same thing. There's machine A, then there is machine B. This produces 50% of the toys. Then definitely machine B will be producing the remaining 50%. So this also will be, even if not given, you should know, because total will always be 100%. All the toys produced by both the machines will be 100. So if they had given 30% machine A is producing, then remaining 70 would be produced by machine B. So this is also 50%. And defective, they have told this one produces 10% defective. And machine B defective items produced will be mostly 20%. Now there's one out of this, you don't know out of which, there's a toy which has been picked up. So given it is already defective. Already given, okay, is found to be defective means it is given defective. What is the probability that it is from machine A? Now it is asked. This is the data. Again the same thing, you have to find A, E1, E of E2, E of A upon E1. The main event will be given thing. Whatever is the given, no, that will be a main event. So A is what? Toy picked. Taken at random means toy picked. What is P of A? Probability that a toy picked is defective. Next we have to find P of E1. So what is E1? E1 will be definitely machine 1. Like how we have two boxes, no? So this will be E1 will be for machine A. So how many toys have been produced? Probability of E1, you can say toy produced by machine A. Yes, sometimes they give the probability in terms of percentage. You can write 50%, which is nothing but 50 upon 100. Don't go to cancel, I'll tell you why. Don't simplify this and write it as 1 by 2. No need. just keep it as 50 upon 100. So that is what your machine A. Same way, A2 toy produced by machine B. So P of E2 will be again 50% will be 50 upon 100. This is done, this is done, this is done. Next, find P of A upon E1. Write P of A upon E1 and start reading it. You have to always read from this. So given E1 means come back and see here. Given E1, means given that the toy produced by machine A, then what is the probability that the toy picked is defective? How you will read this? E1 means given. You have to always start with the word given that the toy produced by machine A, probability that the toy picked is defective. This is given. Probability what are the chances? If this toy is produced from machine A and you're picking from here, what are the chances it being defective? Already given, that is 10%. That is 10 out of 100. Keep it like that only. Then find P of A upon E2. Given the toy produced by machine B, probability that toy picked is A is same, no? Toy picked is defective. A will not change. P of A upon E2. If it was picked from machine B, what are the chances of it being defective? 20% chance. This is also done. Now what is asked? Given it is defective. Given defective means given that it is defective, what is the chance it is from machine A? Machine A means E1. We have to find this. This will be always, I told you, ulta of either this one or this one. If they had asked of machine 2, it would be ulta of this. So given picked toy is defective, probability that it was produced by machine A. Given that the picked toy is defective, probability that it was produced by machine A, that is what we have to calculate. I told you denominator is what? This into this, and this into this. Now I told you numerator either you can write this or this. Which one you write looking at this is E1. So I write this. Now substitute the value. Why I told you not to simplify. Now you see, if you keep the denominator same, it becomes easier to calculate. 50 upon 100, 10 upon 100. So denominator becomes the same. You don't have to cross multiply now. 50 into 10 will be, don't cancel again here, keep it the denominator as it is. So 500 upon 4 zeros, so this will be 500. Make denominator same. So like this, it becomes easier to calculate. Third one, third is on the next page. This one, the third one is here. An insurance company insured 2,000 scooter drivers, 4,000 car drivers, and 6,000 truck drivers. Probability of accidents are, means of truck, car, whatever. First is of the scooter, then is of the car, and then is of the truck. These are the probabilities given of every vehicle. Then the question continues. One insured person meets with an accident. Okay, so given, now you know that one person has met with an accident. So what is the probability that has happened because he was riding a scooter? That he was a scooter driver. So the data, now three things are given. Two thousand. Sorry, 4,000. Yeah. This is 4,000. This is 6,000. Probabilities of accidents are okay. So this is the data given. Now what has been told is out of this, one person given is an accident which is happening. Now what are the chances that it is a scooter driver? The accident is happened because it was a scooter driver. Now there are three things, so there will be three events. This is anyway same, the main event. Then E1, E2, E3 we'll have to find because there are three things. Then P of A upon E1, P of A upon E2, P of A upon E3. So this is the list which we have to find. What is the main thing? Given is person meets with an accident. So it's the same thing when you write P of A, you have to just start with probability that person meets with an accident. No, this is done. Now next is E1. E1 is what? The driver. Insured person is a scooter driver. We use E1 for scooter. So what is the probability that he is a scooter driver? We cannot write now 2000. 2000 cannot be the probability. There are 2000 scooter drivers out of the total drivers. So total drivers will be how many? So we have to always calculate in terms of this upon the sample space, because if it was given directly in terms of probability, it should be always less than half. Probability can never be 2000. So it's what upon the total drivers. What are the chances of it being a scooter driver out of all the drivers? The first thing, it is 2000 insured out of total drivers. So total drivers is how much? 12,000. So just leave it as 2 by 12 on, don't change. Keep it as 2 upon 12 only. Next. E2 is what? Same thing. Insured person is a car driver. So probability of E2 will be 4000 upon the total drive. So leave it as 4 upon 12. Next is we always try to keep the denominator same because it becomes easier later for calculation. So E1, E2, E3 is done. Next, I have to start with this. Start reading this. Given that the insured person is scooter driver, probability that A means person meets with an accident. How much it is already given in the question. Of if it is a scooter driver, then the chances of meeting with an accident is given as 0.01. The same thing. Look for the other two things. Given that 2 times I wrote insured person is car driver, probability that this is given as 0.03. Then P of A upon E3. These are 4 marks problems. If you can understand, well and good. Given that truck driver, probability that he meets with an accident. P of A upon E3. The probability of truck driver meeting with an accident is given as 0.15. So we are done with all these are done. Now we have to see, and I told you it will be ulta fida of these 3 things. Now what is already given that the person meets with an accident, what it is a scooter driver. Scooter driver means E1. This is a scooter driver. So read it as given that person meets, read A, what is A? Given that the person meets with an accident, probability that insured person is a scooter driver. P of A upon A is how much has been asked. So you know that denominator I told you is always theorem of total probability. So what it will be, this into first one, second, this into this, all the three. Now this could have been there, this or this. So this is E1, so this term. If it was E2 here, if they had asked about a car, then this would have come on top. If they had asked about the truck, then this would have been E3 and this would have been on top. Now substitute all the values. So 4 upon 12 sorry, this is 2, no? 2 upon 2. This is 4 upon 12, 0.03 into 0.15. Everywhere 12 is common. Add all the answers. Two decimal here. This is the answer. Fourth one. 60% of the students in the class are boys and rest are girls. So 60% are boys means rest are girls means 40% are girls. It is known that probability of girl getting first class is 0.34 and probability of boy getting first class is 0.28. If the student chosen at random, you know that a student has got a first class now. Given it that a student has got a first class, what is the probability that the chosen student is a boy? So frame the data. From now onwards, I'll just frame the questions and give you all that calculation part you'll have to do. So 60%, there are girls and there are boys. Here these are 60% of the girls, and here boys are, sorry, boys are 60% and remaining are girls left. So 100 minus 60%, that is 40% of girls. From here we get first class. The probability of boys getting first class is 0.28 and probability of girls getting first class is 0.34. Now out of this there is one student who has been picked. So given is what? Student got first class. Now what it is? It is a boy. Now there are only two things, boy and girl, so there will be only two events. This will be, by now this you all should know by heart, this order. It will never change. Whether it is for total of theorem, this or this, whichever it is, sequence will not change. So P of the A is a main event, student gets first class. Probability E1 is number of boys. How many boys are there? 60%. Keep it as that one. E2 is what? Number of students in the, number of girls in the class. This somehow you can frame in your own words, huh? This shortcut also you can do. Number of girls also. So this is 40%, 40 upon 100. So this. Now frame this one. Given that the students in the class are boys, or you can say selected from class. Just write this, huh? Class is a boy and then student selected. Suppose if I go give you a task, go pick one student from one class. So there are chances either you could pick a girl or you could pick a boy. Okay, the student selected. Suppose it's a boy. So what are the chances? 60% chances. When you go to select a girl, there are 40% chances. Select a girl. Next is P of A upon E1. Given that selected student is a girl, probability that student gets first class. So what are the chances that girls getting first class? P of A upon E1 is 0.34. Well, same way find P of A upon E2. Given that Same thing. What are the chances that if you select a boy, what are the chances that he will get a first class? That is given as 0.28. This is given in the question. Now what you have to find? Given that already gets a first class, what are the chances it's a boy? Wait, I made it ulta, 1 second. E1 we had taken for boys, no? The box. That same thing you have to take, E1 is for boy. Box I had taken boy, no? First. This E2 is for girl. Just correct this. The same sequence you have to take, you cannot shuffle. If I had taken E1 for a boy, then A upon E1 also we have to select for a boy. It will be E1. Given that student gets first class, probability that select so this is what we have to calculate. Now because this is E1, this we have to write on top. Then calculate. Make 100 common everywhere. 100 will cancel. Okay, then calculate and write down. So that will be 0.16 to 0.28. Multiply and write your answer. Calculate. This will be 2.8 into 6. And that is 6 now. 1 second now. So 6 is the 48. And then simplify. Okay. I'll stop here. Next class I will finish with the chapter. There's remaining 6 problems I'll solve. And then if something is left out from the chapter, some miscellaneous problems, that also I'll do. And then wind up with the chapter. Then only one chapter remains, that is last, application of derivatives.